Okay, stats. Let's get it going and let's find the linear correlation coefficient, the R value, on our example of the hours of study exam scores. So before we can calculate it, I've got all my hours of study and my exam scores, my X's and Y's, but I need my X bar, my sample standard deviation, my Y bar, and my sample standard deviation of Y. I'm going to go ahead and tell you what those are. You can put the lists in your calculator to get them, but I'll tell you that X bar is 4.17. The sample standard deviation of X is 2.64. Y bar is 73.83. Sample standard deviation of Y bar is 14.9. So that means we need to calculate all of these. So we have to take our X values, subtract X bar, and divide by sample standard deviation of X. Do all of those. So that means 4.1 or 6 minus 4.17 divided by 2.64. Same thing with 2 minus 4.17 over 2.64. And this one is negative 0.82. Repeat again for 3. It's negative 0.44. Repeat again for 8. Minus 4.17 divided by 2.64. This one is 1.45 hours of study. This one is negative 1.20. And the last one, 0.31. Now we have to do the same thing with our Y values. So our average Y is 73.83 and divide by 14.9. So we take 82 minus 73.83 over 14.9 and we get 0.55. Repeat the same thing for 58. Get negative 1.06. Again, all the way down, we get negative 0.26, 1.62, negative 0.93, and 0.08. Now, once we've done all of these, we have to multiply the corresponding pieces, because it says they get multiplied together. 0.69 times 0.55 is 0.3795, and you keep going all the way down, multiplying our answers for the two columns together. 0.82, 1.06 is 0.8692. Negative 0.44 times negative 0.26 is 0.1144. 1.45, 1.62 is 2.349. Negative 1.20, negative 0.93 is negative 1.116. And 0.31 times 0.08 is 0.0248. Now what it says for R is I have to add all of these things up in our final column and divide it by, since there's 6 samples, 5. So my R equals this total of this column here, total divided by 6 minus 1, because there's 6 samples. So what do we get? The sum of all of these numbers, if you put it in the calculator, is 4.8529 divided by 5, which is about, in 2 decimal form, 0.97. Now we talked about earlier, the closer you are to 1, the stronger a positive relationship you have. And 0.97 is really close to 1, so that means there's a very strong positive relationship from the data in the last video. This only had 6 data points, but that's how long it takes to calculate it by hand. It's not particularly pleasant, it's tedious, but your calculator can do it. Following these steps, depending on what kind of calculator you have, they may be different. There are also a lot of online calculators that can do this, so if you aren't sure how to do it by hand, you can always use Google, type in regression calculator, and most of them that pop up will work. But if you want to know how to do it on your calculator, I would suggest, depending on what kind of calculator you have, this works for one type of calculator. I'm pretty sure the TI-30, but if you have something like a graphing calculator or something else, you're going to have to look up how to do it there, your lists, because it'll be different. Or you can just use an online website. Now, how close to 1 do you need to be to determine that there's a strong relationship? There's a test to determine that. So testing for a linear relation, determine the absolute value of the correlation coefficient. So if it's negative, just chop off the negative. If it's positive, leave it alone. Now there's table 2 from Appendix A, and how strong it has to be depends on your sample size. And then if your absolute value of so if the number you got after you took the negative away is bigger than the critical value in the table, then it's a strong relationship. So if we look at our last example, here's a cutout of the table. We had an R value of 0.97 and there were 6 numbers. Now if we look here at the column for 6, it says it needs to be at least 0.811. Is 0.97 greater than 0.811? Yes. Conclusion that there was a strong positive relationship. What about the correlation coefficient for the absences versus our course grade? Now I'm going to tell you what the R value is when we calculate that. You can do it, go through it yourself if you want to. But we got a correlation coefficient of negative 0.899. And in that one, there were 7 data pieces. Now we said if you're going to compare it to 7 up here in the table, it needs to be bigger than 0.754. And of course, negative 0.899 isn't bigger than a positive number, but we always get rid of the negative entirely. And positive 899 is bigger than positive 0.754, which means there's a strong relationship here as well. But because it's negative, there's a strong negative linear relationship. And that's all for 4.1. One section to go.